Oh, hey, didn't see you there. Welcome to day 5 of Advent of Code. My name is Ryan. We've been doing these for 4 days now. We got a streak going. It's pretty good, and we've been doing them every day in this weird language called Elm over here. So if you haven't seen the other videos, they probably explain it a little bit better than this one does. But Advent of Code, every day we get a problem for 25 days, building up to December 25th, and I just solved them in a video format so you can see how I talk through the problem and kind of solve it from scratch. So all we have here is just a little bit of code for printing out some strings. You'll see this at the start of all the videos. So if I have hello here, we're going to see hello. So every puzzle is a little bit different, and it always involves elves trying to do something. They're going through a jungle. I don't know. Yeah, we've got 8 stars so far. Today we're going to get 9 and 10, or we're totally going to get wrecked. Yeah, let's dive in. Let's see how it goes. Okay, day 5, supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of the crates and the rearrangement procedure, which is our puzzle input. So here's an example here. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates, so it looks like N and Z. Z is on the bottom and N is on top. Stack 2 contains 3 crates from bottom to top. They are M, C, and D. And finally, stack 3 contains a single crate P. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above arrangement procedure, 1 crate is moved from stack 1 to stack 2, resulting in this configuration. So if you move 1 from 2 to 1, that means we're going to move we're going to move D over here. So we have D on the top, N and Z. Okay, great. Second step, these crates are moved from stack 1 to 3. Crates are moved one at a time, so the first crate to be moved, D, ends up below the second and the third crate. So move 3 from 1 to 3. So D and Z, they all end up over here. Got it. Then both crates are moved. It keeps going. The elves just need to know which crate will end up on the top of each stack. In this example, the top crates are C, M, and Z. Okay, so we combine them together to get CMZ. After the rearrangement procedure completes, what crate ends up on the top of each stack? Okay, great. So what we're going to do is we are going to try to solve the puzzle with this example input here. So I think this is what our example input looks like. Let me just check to see. Okay, great. So ours is just going to be more. What we're going to do is we're going to just get this printing on the screen for now. And it looks like we've got everything, all these lines here. And what we want to do is we just step by step, we're going to use kind of this pipeline style to break the string apart and get all the information we need. And that way we can perform some logic. So let's do, let's start with a string.split, and let's just split on this kind of double, this like blank line here. So this is a new line and a new line. So hopefully this will give us the state of the puzzle as the first input, and then it's going to give us the instructions as the second input. So what we can do is we can say what are we going to call this? Like to puzzle. Oops. I think the Steam's still open, huh? All right, well, we could probably close that out. And in case you're wondering, I'm making my thumbnails here using GIMP, and that's also open. So I think we're good now. Okay, back to the puzzle. Cool. So what I want to do is make a data structure called puzzle that just captures what we need to worry about. So a puzzle is going to be a list of instructions, and then it's also going to be kind of like the current state of the puzzle. So I'm just going to call this state because I'm lazy and I don't really know what to call it right now. And then I'm going to call this next part instructions. So what I want to do is I want to use, I want state to be my, the structure that represents kind of like these three stacks. So I think state is going to be a list of stacks. So we kind of have each crate in a stack here. So I think maybe stacks can just directly be what we're working with here. And then I also want to be able to access them by index. So I'm going to reach for an array for this. So in Elm, lists are the primary data structure, but there's also other helpful ones you have access to. So arrays, dictionaries, sets. Those are some other ones you might find. So a stack. A stack, I think we're actually going to represent with a list. I think we're just going to be a list of characters here. So stacks, it's an array. So 1, 2, and 3. We have 3 stacks here. And then each stack is a list of characters. And we're going to use a list for this. Lists are really good at appending from the front and taking from the front. So I think they'll make a really good stack data structure because we can use head to kind of like, or take to like pop things off the front. And then also we can pop, we can like push items to the top. And then instructions finally, like if we hit compile right now, we're going to get a few errors. One is toPuzzle isn't defined, but the other one is that the instruction isn't defined. So an instruction has an amount, there's an int, it has a from, and then it has a to. So for the instruction line that says move 3 from 1 to 3, amount would be 3, from would be 1, and then 2 would be 3. So that's how I want things to be represented. But in order to get there, we're going to need to have this function that interprets both of these lines and turns it into something we can work with. So let's get started with kind of decoding that. So toPuzzle, not every input is valid. Like if this was the input, this wouldn't be a valid puzzle. So we're going to say that this takes a list of strings because we've split it already. There should always be 2. But it's going to take a list of strings and maybe we're going to get a puzzle back. So let's try that out. So toPuzzle, we're going to have our list strings, and then we're going to say in the case where we have a list of strings, we'll do some destructuring here. This is going to be the puzzle string, or like the stacks string, I guess is probably a better way to put it, so it matches with this. And then this will be the instructions string. So this is going to be all those multiple lines of instructions. Instructions string. So if we're in this case, for now what I'm going to do is I'm just going to hard code stacks. It's going to be array.empty. And instructions is going to just be an empty list of instructions. So we'll do that. And then for every other case, if we have like 1 item or 0 items or 3, every other case, we're just going to say that this is not a valid puzzle. And if we want, we can even give a reason it's not valid. So like we can use a result type and say like, this is okay, or we can say puzzle input invalid or something. To keep things simple, I'm going to start with a maybe, and then if it becomes useful to get information about what's wrong, that's when we'd use a result. But I think for advent of code problems, we can kind of assume that the input's going to be valid. We don't need to kind of track information about that. So because we hit this first branch, because we did actually have 2 items in our thing, we're going to end up with this branch getting hit. As opposed to if there was something invalid, let's say this line was missing from the puzzle, we'd be in our nothing case, which would kind of be like, this is an invalid input. We can't really solve the puzzle with that. So I think the interesting part is going to be, I think the length of this line is going to determine how many columns there are. So, or how many stacks there are. So if there's 3 plus 1 plus 3 plus 1 plus 3, so if there's 11 characters in this first line, we know there's going to be 3 columns. We can kind of ignore this last line of input, but let's just focus for now. Let's this will be like I like to do this in code that I use at work, where I add a debug log to remind myself to do something. So to do here, parse instructions. So I'm just going to add this here. What I'm going to do here is I'm going to say parse stack string. So parse is just a fancy word for saying turn this kind of raw text here into an array of stacks. And we'll make sure that that always works by just saying that if there's any invalid input and we run in anything weird, let's just return an empty array. That way we don't have to worry about the data structure. So this thing here is going to be responsible for turning this into a list of stacks. So let's make it. I guess 2 stacks is probably a more consistent naming convention that we have here. So let's keep going with that. Okay, so we take the string in, and we're always going to get an array of stacks. So we're going to say case string.split. On new line, there's also a built-in Elm helper called string.lines. What we can have is, if we have an empty list, we really can't do anything. We don't have like a single string to go off of. So I think in this case, we'll just do our array.empty. But if we do have at least one thing, we can say the first line, we can use that to determine the length or how many columns we have. So let's just kind of, let's just start with this. So if we have the first line, what we want to do is we want to find the number of columns. So the number of columns is just going to be an integer and say how many columns we can expect to parse from this entire thing. And so what we're going to do is we're going to take the first line. We're going to get the length of the string. And then I think what we want to do is divide that by 4. I guess we want to add 1 to it. So we're going to take the length. We're going to add 1. And then I'm just going to do some debug logging here and just make sure that I'm on the right track. So I'm going to say length plus 1. And then I'm just going to return an empty array to make Elm happy here. Oops, I'm going to undo that. I did a little format here, but that got rid of my I got rid of the formatting of this. Great. Okay. So if I compile this, hopefully we'll have some logs here. So it looks like 8 is the length of the first string. So we've got the first line. Oh, you know what? Lines is probably trimming white space for us. So let's make sure it doesn't do that. Let's just do a split. Oh, that's too bad. Oh, it's the string trim that's messing with us. So the string trim is taking off the first bit. So let's not use string trim here. Instead, let's just paste this input a little bit nicer. So the string trim is actually what's giving us trouble. Okay, so back to the logs. It's very good that we did the debug log here, otherwise the puzzle was going to be really confusing, and it was going to be because of like line 80. String.trim was getting rid of this white space too. We don't want that. We just want to get rid of that first new line, is why I was using it before. So now we have 12. And so I think if we just divide this by 4, so I'm just going to do like an inline divide operation. Oops. You'll see the length plus 1 is this, and then after we divide by 4, oh, sorry. You know what? I can't be doing this. This doesn't make sense. So this is going to be the number. We want to take that number, divide it by 4. What I accidentally did was 4 divided by 12. Okay, so that's going to give us 3. So that's how many columns that we have. So I can get rid of these. And we know that at least for this input, we're picking up that there are 3 columns. Now that we know that there are 3 columns, what we can do is we can basically go through each column, so each line one at a time, and we're gonna just build up a stack for each one of these. So I think the idea that we want here is, I think we're gonna want to list fold L, and this is gonna be like add, easiest way to do this. Add line to stack. We kind of want to work from the bottom up. This is gonna be a challenging one. Just trying to figure out how to parse this. Try to understand it by looking at this. So these are all the characters that we get in our string. So all of our strings are looking like this. So what we need to do is we kind of need to group up these strings like this. And then I need to push the Z on the first one and push the N on the first one. So I'm trying to figure out the best way to do this. Maybe I can start by figuring out how tall this is. So let's get the height. Sorry, I'm gonna put this here so this is still valid. Height of tallest column. And then all I'm gonna do is I'm just going to take the so we'll do this. Lines is going to equal the first line. I'm just going to put these back together. So lines here is just going to be a list of our strings. So in this puzzle example, we have 1, 2, 3, 4 items in that list. And so what I think I want to do for height of tallest column is I want to take the length of these lines. So if I do list.length of lines, I can also say lines and then pipe that in a list.length. It's totally the same. Because of this, I think I want to just subtract 1 from that. So length minus 1. So I think if I do this, I debug.log, the tallest column, we're going to see that 3 is the height of this tallest column. And then what I want to do is I want to scan from top to bottom and split by the number of columns. Number of columns, 1 through 3. Okay. So I'm going to start with a range, which is just going to be a list of ints. This is going to go, I'm going to use this list.range function, which comes with Elm. I'm going to say go from 1 to the number of columns. This is going to create a list of numbers from 1 to 3. So just to show you what I'm talking about. This is going to be a range. I don't need this anymore because I'm pretty sure that we got it right. So what I'm going to do here is, here I'm going to have 1, 2, and 3. So if I have 1, 2, and 3, I think for each line, I can use 1, 2, and 3 to grab like the first 3 characters and see if it's blank or if there's actually a value there. So we're going to start with each line. List.foldL. So fold L is going to work left to right, or top to bottom in this case. So it's going to start with this one. And what it's going to do is it's going to get that single line. And then what we're going to be doing is we're going to just be building up a data structure where we're keeping track of both the height. I guess we're just going to be inserting items into the array at that part. So let's say we have an array. For now, we're just going to return the array. We'll start with an empty array. And then what we're going to do is we're going to take the lines. We're going to do this for each item. So this is going to be a function called add line to array. So again, add line to array. It's going to take in a line. It's going to take in our current array, which is just an array of stacks. The one thing I really do like about Elm, this problem's kind of overwhelming to me, but there's a lot of steps. But it helps to be able to do things in small steps and get feedback as we go. So even for really big problems that, you know, like I'm talking through it like real time, it's really nice to be able to just print out, you know, like what we have. So if I compile this, what you'll see in the output is I still have an empty list, because that's what I'm doing. I'm taking an empty list, and then each time I come through, what I'm doing in this function is I'm just kind of ignoring the line. But you'll see that each line is coming through here, and we're just always returning the empty array. So the empty array comes in, and then for each line, let me get rid of this, you'll see that we get line, 1, 2, 3, CMP. I think this is going from top to bottom, which is confusing. So it's printing out this one first, and then it's printing out this one, and then it's printing out this one. So I think we want to ignore the last line too. How do I drop the... This is going to be dumb. I'm going to do a list.reverse. This will make it so I don't need this. Basically, I want to get rid of the lines, this like 1, 2, 3 line. So what I'm going to do is I'm just going to simplify how lines looks. And I'm going to comment this out for now. So if I reverse the list, oops, what did I miss it? Oh, you know what, I need something here. It's just for the let expression. So if I reverse the list, you'll see 1, 2, 3 is first. What I want to do is then I want to drop the first item from that list. Now you'll see that it's gone, and then in order to restore the order that I had. Actually, I kind of like this. I kind of like these reversed. This will make it easier to add to the front. So this will be reversed lines. Great. So these are the reversed lines here. Oops, and then finally, take the reversed lines. I could use fold L, or fold R instead of fold L, to go right to left. All right, I'm going to try to make this as least confusing as possible. So I'm not going to be talking about reversed lines here. Instead, I'm going to have these lines, and I'm going to work my way from right to left. So as these things get printed out, you'll see that. So we printed out the lines up here, and then this got printed, and then this got printed, and this got printed, and hopefully we'll be able to push onto our stacks in a way that works. So what I'm going to do is for each line that comes in, I'm going to split it. I'm going to use list.range, or this range here, to kind of like insert a bunch of things into the list. So I have my range. My range is 1, 2, 3, 4. I could also have it be 0, 1, 2, which might be easier for insertion. I don't know. I think what I want to do here with this array is when I get to this line, I want to split it. I want to basically like access into this line depending on which item I'm at in the range. So just to give you a sense of what I'm talking about here, because I'm talking very abstractly right now. I'm gonna just call this thingy because I don't know what to call it yet. But I'm gonna start with the range, and we're just gonna print that out. So we're just gonna see for each line what is thingy. So thingy 0, 1, and 2. We're gonna do another list.foldL, but this time it's going to be going through each thing. So handle each index. So handle each index. This is going to start with the array that we're given. I think we're just going to return this. So this is going to be the result of add line to array. Look, I didn't have to name thingy. Anyway, it'll take an int, so it'll take 0, then it'll take 1, then it'll take 2, and it's just going to also be modifying the stack one step at a time. So handle each index. I can probably just move this outside of this function, just to make it easier. What it's going to do is it's going to take in the line. I want to make sure I pass the line in here. It's going to take in the line, because I pass it in as the first argument here. It's going to take the index, where I should be looking, like which column I'm in. I can call this column index to make it a little bit clearer. And then it's going to take my array and return an array. So each time I come through, I think what's going to happen is it's going to say, debug log line print this out for you. Hopefully you'll see that for each line it should say 012, 012, 012 over and over again. And then we'll see add line to array at the end of all that. So here you'll see 012 for ZMP, and then it'll say add line to array with the empty list, and then it'll do it for NC, and then it'll do it for this D, and it'll work its way up. So what I want to do is at the very bottom, I'm going to try to grab this character here. So I need to get the string at index 0, for example. So I'll say string at index will be a string. So how we get the string at that index is we are going to use some of these string functions here. So let me take a quick look and see if there's like a substring or a slice or something like that. Split we've used, words we've used. Here we go, slice. So if I say 0 to 6, it's going to get me the first 5 or 6 characters from the string. So what I'm going to do is I'm going to use string.slice. I'm going to take the column index, whatever it is, so if it's 0 or whatever, I'm going to multiply that by 3. And then I'm going to go until the column index, or sorry, not 3. I'm going to go by 4, because 4 is the width of each column. Like if you look at the input, 1, 2, 3, 4 is how much I need to skip each time. So if the index is 0, this will be what I select. If the index is 2, this will be what I select. Or sorry, if it's 1, it'll be this. And if it's 2, it'll be this. So we're going to multiply by 4. Now we do the same thing, and we want to grab the first 3 characters of that string. So just to make it clear, what we're going to end up doing is we are going to print out the string at index for each one of these. So hopefully what we see in the output, and this is going to be going from bottom to top. Let me go to this parse instructions thing. I think this is adding confusion. Is we're going to see Z, M, P, N, C, blank, blank, D, blank. That's what I'm hoping for, at least. No, but I get a compiler error because I screwed something up. Oh, I need to give it the string I want to work on. So the line is the third input here. So slice takes in 3 arguments, takes the start index, the end index, and then the line that I'm working on. I could also pass the line in like this. It's not a big deal. So again, what we want to see is Z, M, P, N, C, blank, blank, D, blank. So we see Z, M, P, N, C, blank, blank, D, blank. So that's good. So we're still in a very abstract place, but we are working our way through the string top to bottom. And what's good about this is we can extract like the value out. So if we wanted to get even more specific, we don't really care about these brackets surrounding these strings. All we care about is, so this would ignore like the first bracket. So if we do this, you'll see the first bracket goes away on all these. And then if we just grab a little bit less, this will ignore the second bracket. And so what we're left with is all of the letters in a very specific order, and this order is going to help us out because if we know the column index and we know the string that we want to insert, we're going to be able to update this array. So we're going to be able to get the array, or get the stack at that index. So stack at index. How this is going to work is we are going to take our existing array that we're kind of building up. We are going to try to get the value at the current column. So can we find a stack? The first time we come through, the array is going to be empty, so we're not going to find anything. But let's say this is our first time through. 0 is our column index. What we want to do is we want to see if we can find a stack that's already defined. So at this point, it would be a maybe stack. But what we're going to do is we're going to say if we don't find something, that's totally okay. We're just going to create a new stack by just creating an empty list. So we can use this syntax, we can use list.empty, they're both equivalent. And then the valuable part here is that we're going to modify. This is like the one line that's actually going to update our data structure, so we stop returning nothing. So hopefully once we add this in, we'll be in a good spot. At this array, we are going to set the value at that column index to be the updated stack. So what's the updated stack? It's going to be one where we check to see if we have a letter. And if we do, we're going to insert that letter to the front of the stack. So if string dot is empty, string index, then we're going to leave the stack at the index alone. Otherwise, we are going to put our letter in the front of the index. So I think string and index could just be called letter. And then this we said was going to be a list of characters. Let's just make this a list of strings. It'll make it easier to put them together at the end. I think we'll find out. So we're just going to leave that as a list of strings. And then finally, we're going to say stack at index, and we'll say, let's put the letter in the front of the stack. So this is the idea of us like pushing to the top. So hopefully this all worked. What we're going to end up with at the very end, list.empty. What I wanted to end up with is a list of these stacks here. So lines, add line to array, and each, array.set column index, updated stack. Each. Did I do anything to stacks? Fill an empty list, huh? So let's take a look at some of the debugging and see what we're ended up with. So this is going to be the end of handle each index. Let's see what we have. So it looks like every time this is called, we're getting an empty list. So maybe we're always up. Stack. Something I'm missing. So we add a line to the array. You can see that we're getting Z, but then we end up returning an empty array. Column index. Let me just print out column index and see if that's what I expect. So debug.log column index. Debug log returns a value, so that's why you'll see me do this underscore equals every now and then. So let me just print out what the updated stack is. So we're gonna do the same exact strategy. I'm gonna use it backwards. Here, updated stack. So let's take a look at what's going on. Okay, so here I have Z. It sees the column index is 0. It adds that to the stack. It returns that. So updated stack is this, column index is 0, array.set, and I'm returning the new array. Let me just see if I'm screwing up. You know, I might be screwing up. I think set doesn't insert unless if the index out of the range, the array is unaltered. Okay. So I have to make the array have a certain length. Okay, so I have to say initialize 3 and then just return empty lists before I do any of this. So I think the array empty is what's screwing me up. So if I know the length, I need to say array.initialize how long the length of my array is. So what is that? This is funny. This is all messed up. The number of columns. It's the same thing, but just with an empty list. Okay, we have it now. Sorry, so the issue there was array.set does not, if you look at the docs here for how array set works, is that it sets an element at a particular index and it returns an updated array. If the index is out of the range, so we had an empty array before, the array wasn't being changed. So each time we weren't actually inserting anything into the array. So that's no good. But now that we have this, now that we're here, we do have an array from a list. So the first one, what is that? Oh, it's not empty. This is inserting things that I don't want. So really, we want to know if the letter is just white space. We can get rid of all this debug logging now that it seems to be working. So here's what you'll see is N and Z. From top to bottom is what we'd expect. So right in the beginning, you have N and Z, and then we should see DCM for the other list. So DCM, and then finally P for the third list. So I think we're in good shape. Get rid of all this debug logging. Finally, I think I'm printing out the lines here. And then there's like some weird syntax highlighting stuff that's broken, but figure that out. I think it's just from this. So I'll get rid of these quotes. I think that's all that it was. Okay, great. So we have our initial stacks. That's just the first half of parsing the puzzle. The second half is the instructions, and I think the instructions are going to be a lot easier to deal with. So what we're going to do is we're just going to call list.filterMap. We're going to take the instruction string. We're just going to split it into lines, string.lines here. And then we're just going to say toInstruction. So toInstruction is going to be a lot simpler than all this crazy stack pushing stuff. I'm going to put it at the bottom so it's a little bit easier to look at the instructions here. And what we're going to do is we're going to take a string like this, and we are going to just turn that into that data structure that we saw before, where it had an amount, it had a from, and a to. So this is an example of the input. We're going to take that string, or we're going to return maybe an instruction. That's assuming that we can correctly parse this. Anything that's invalid, let's say that there was a typo here and it said mo, we're going to ignore that input, so that's okay. And then toInstruction is going to take this. I'm just going to do this, nothing. I'm getting some syntax highlighting problems with Ellie. Let me just format and see if this changes anything. Okay, that did it. Weird, right? Okay, we're back. So this is still going to be an empty list. That's totally fine. But what I need to do is I need to try to break this apart and see if everything works. So the way I'm going to do this is I am going to split on spaces. Right. So case string.split. You can do, I think, words, string.words line. So if we have the move, and then we have, so I'm just going to call this move amount from, I'm going to put an underscore there. So this will be the from value. This will be 2. And this will be the to value. So the things with the underscores are things that we're not worried about. They're just kind of placeholders. So if we're in this situation, we're just assuming that, I think we can do this. I don't know if we can do this. Let's see if we can do this. So amount equals amount, from equals from, to equals to. I don't think this is going to work because we need to turn these into integers. So what we really want to do is maybe .map3. We'll use this instruction alias as a constructor. And then we're just going to say string.toInt amount from to. Otherwise, we're going to fail. I think this just works. Awesome. That's great. Because, yeah, so pattern matching in Elm is really good. I didn't realize we could actually like match on these words. So we broke apart the words. We grabbed these. This is like the string value. That's why I had to do the toInt, because it's going to be 1 in quotes. And so all these things here are, oops, they're not numbers yet. So that's why we did toString. ToString is an operation that could fail. That's why we had to wrap it all in this maybe stuff. And so map3 is saying if all 3 of these went okay, then we actually do have an amount integer, a from integer, a to integer. And then in Elm, type aliases for records are also constructors. So instruction is a function that takes in the amount, takes in the from, takes in the to, and returns this kind of instruction record value. So that's why everything's working out for us. Okay, so we did all that. That's just the parsing. I'm going to save because that's a lot of progress. But now we need to do the part where we start to simulate each thing here. So what I want to do is I'm just going to make a function called step. All step is going to do is we're going to also wrap this in a maybe map. What step is going to do is it's going to take in a puzzle and return like the next kind of step for that puzzle. So it's just going to kind of like move. It's going to take this first instruction and it's going to move the puzzle to the next state. So case puzzle.instructions. If we ever are out of instructions, it's totally fine. We're just going to return puzzle as is, and we're just going to leave it alone. But if we do have an instruction to go off of, and then we have the remaining instructions. So the first instruction, the remaining instructions. If we're ever in this scenario, we're going to be able to do something to the stacks, and then we're going to basically update the puzzle. So the puzzle's instructions, we're going to remove the first one. So we're just going to do the remaining, and then for the stacks, we're going to say perform instruction. And that's going to take first instruction, and that's going to take the initial puzzle stacks. So we only have one more function to implement here for this. So you'll see Elm will let us know, hey, what the heck is perform instruction? We didn't make it yet. So perform instruction is going to take in an instruction, and then it's going to take in an array of stacks. And it's going to return us the new array of stacks. So once the instruction is completed, what's the updated stack? What does that look like? Cool. So then these are our stacks. All right. So if we didn't want to do anything, we would basically return this and then nothing would change, except we'd lose that. We're losing that first instruction. So if I called step twice, you'd see that there'd only be one instruction left. Or sorry, 4 instructions left. Or sorry, 2. So there's 4 instructions when we start the puzzle, right? So each time I call step, it's going to take one more off the queue here. Great. And then I think, yeah, so the idea is that at the end of this, we would be out of instructions, and then we'd have like the answer. But our step function is not actually doing anything yet. We need to update these stacks to move things from the right place to the right place. Cool. Okay,
So how do we do that? So an instruction has an amount, it has a from, and it has a to. So what we need to do is we need to find the from stack, the to stack, and then we need to be able to modify these things. So let's just start with that. So let's pretend we don't mess with these at all. So the from stack is if we go to our array and we try to get instruction.from -1, remember, because the instructions are talking about 1, 2, and 3, but our array is storing things as 0, 1, and 2. This might be a reason that we should have used a dictionary instead of an array, but I'm not upset. I think it's going to be just fine. And then, of course, we're just going to have some fallback. Whereas if we ever try to get something and it's out of range, we're not going to have like a maybe. We're not going to deal with that. We're just always going to get a stack back. And then finally, we want the to stack. Let me just kind of copy this. The to stack is we're going to try to go to the index of the to column, get that from the stacks, and then as a fallback, we're just going to say it's empty. So this should really never happen, but in order to make the compiler happy, it is possible that the puzzle input, says like, hey, from like 99, like that's a valid integer, but that would break our simulation. So in that case, we're just going to keep running the program, and we're just going to nothing would happen because array.set, which we'll use in a second, won't actually insert onto the stack. So anyway, what we need to do is we need to figure out how many things we need to pop from the stack. So I think this is a perfect use of so there's going to be the new from stack, and there's also going to be like a range of like how many times we're going to perform this operation. So range is going to be a list dot range from 1 to the instruction amount. So if it said move 1, this is going to be a list of just 1. You'll actually see here what I'm talking about. Let me just put this out. This is going to be range. So when I run this program, what you're going to see is because this first instruction is saying move 1, you're going to see 1 is in our range. But if the first instruction was move 3, let me just hide this for a sec. You'll see 1, 2, and 3 will be at range. Oops, I'm deleting lines on accident. Okay, great. So what we want to do is we're just going to kind of loop through this list. And then that's how we're going to update these stacks. So stacks array.set. This is going to be the from index. So this is going to be the updated from stack. So hopefully there'll be items removed from this. We're going to define this together in a sec. And then we're going to have the updated to stack. So what we want to do is we want to get the items to transfer from the one and then put them on the other. So if I was moving 3 items from, let's just think about this first input. So if I needed to move 2 items from 2 to 3, I would want D to go here. I would want like this to be D. And then I'd want this to be C. And I'd expect. So D and C would get pushed in that order. So what we're going to do is we are going to have the updated from stack and the updated to stack are both going to be the result of the same operation. So updated from now I'm just going to call this updated. And then I'm just going to say from dot to. And then this is going to be another stack and another stack. This is going to be the type of this. But how it's going to work is we're going to start with our range. This is how many operations we're going to do. We're going to do list.fold. And then we're going to just ignore the number. This integer doesn't really matter. It's just going to allow us to loop a certain amount of times. And so this is going to be our initial, this is going to be like our initial record. We're going to return a new record. And initially, our record is going to have from stack equal from stack, to stack equal to stack. So these are like the initial values that we have here. So initially, before we moved anything, we have this and this. That's going to be the initial value. And then we're going to say move item from one stack. Or yeah, move item onto other stack. We're very close. It's been a long journey, but we're going to get there, I promise. Move item onto other stack. Great. All right, so our input is going to be an int. We're just going to ignore the int. We're going to take whatever the heck this shape is, and we're going to return this shape. So ignore that input. We're going to have the from stack. Sorry, we're going to have the, I'm just going to call this the record. Here. So we're going to return the record. I'm not going to mess with it for now. Oops. I think typo somewhere. Oh, I forgot to type stack here. Probably did it twice, yeah, because I copy pasted, right? So it's definitely in every spot. Hey, that's one way to get consistency. Okay, great. So this didn't do it yet, but what it does do is it allows us to kind of modify things as we go. So what I mean by that is we can take the certain amount of like items to move. This is going to be a list of strings. This is just going to be like the amount of things that we push off. It's always going to be one, but it's going to be a list. So we'll say list dot, well, an easier way to do this is to say from stack equals, I will do list dot drop. So we're going to drop one item, the from stack. So each time we step through this, I'm going to kind of do one thing here, and then we're going to push. We're going to take the first item, basically the item that we dropped. We're just going to put it in front of the existing two stack. And I think this will just work, okay? This is crazy code. But the idea is that this will remove an item from the top of the stack. This will take whatever that item was, and then it'll put it in the front of the other stack. At least that's the idea. So if we look at our results, now we have DNZ CMP. So let's see if I screwed it up. DNZ, CM, and P. Okay, and let's step one more time and see if we end up with an empty list, CM, ZNDP. So if we call step one more time up here, hopefully that's the state. Great, so we have an empty list, we have C and M, and then we have ZNDP, which is the next state. So empty list, C and M, ZNDP. I'm going to just kind of go through these to sanity check, maybe catch a potential bug before I use my puzzle input. MC, empty list, Z through P. MC, empty list, Z through P. And then finally is CM, ZNDP. Great. Okay, so CM, ZDNP. So at the end of this, we're almost done. What we need to do is we need to get the first items from all the stacks. So get message from puzzle. And again, this is a maybe map because this gave us a maybe puzzle, and we've kind of been living in like this this happy path where we're only thinking about when we do for sure have a puzzle. We're not worrying about the nothing case. So puzzle, this will give us a string. What we're going to do is we're going to say, give me the puzzle. I want to take the stacks from the puzzle. I'm going to do array.toList to get me a list of lists of stacks. I'm going to do list.concat map? No, map. So then I'm going to take the first item from all these. So for each stack, what we're going to do is we're going to get the head. That'll give us a list of strings, and I think we just do string join this. And hopefully we get CMP as our answer when I hit compile. CMZ. Oh, CMZ, right? Is that right? CMZ, because Z is at the top. Whew. Okay, so that's the right answer. There's only one thing that's not going to work, and that's I manually entered step 4 times. So what we want to do is step until we're out of instructions. I'm going to just call it that because that's English, so I'm going to do it that way. So if you give me a puzzle, I'm going to do this. So all this is going to do is this is going to take the puzzle. Next puzzle is also going to be a puzzle. And I'm just going to say if list.isEmpty, next puzzle dot instructions. This is the part where I accidentally type this and then do an infinite loop. And then you find out that Elm secretly does throw runtime exceptions, and my whole my whole illusion is lost. List is empty. So if there's no more instructions, then we're just going to return the next puzzle, and that's it. Otherwise, we're going to keep simulating. So we are going to step until we're out of instructions, get the next puzzle. So this should still give us just CMZ. Awesome. But this time I didn't have to type 4 steps. So I think this is the answer to part 1. Let's save this. That was a lot of, we did a lot of data structure stuff. So I'm really hoping that I save this. This is day 5, part 1. I like to keep all these URLs here. So in the description of the video below, the answer is going to be available just underneath my face. So you can run this yourself. But what I'm going to be doing is I'm going to be taking this puzzle input, and let me just make sure that, okay, that still works. And I'm pretty sure this breaks, right? Yeah, that's wrong. So all that matters is that when I paste my puzzle input, I need to make sure that I paste it like this and not do a new line on accident. So let's take our puzzle input and let's see if it scales for 9 columns. I'm nervous because I don't want to troubleshoot this. Okay, I just want to make sure that I pasted it. Great, so it is all one line. Awesome. All right, I get RFFF WBPNS, so that's letters at least. Oh, thank you. Sick. Okay, we got the right answer. Now they're gonna make it a little bit tricky. They're gonna give us a part 2, and we're gonna see how well structured our code was and how easy it's gonna be to solve a slightly different problem. Okay, deep breath. I'm gonna take a sip of this cherry sparkling water because I earned it. So 1 sec. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a Crate Mover 9000, it's a Crate Mover 9001. The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Ah, this is great. Okay, moving a single crate from stack 2 to stack 1 moves the same as before. However, the action of moving 3 crates means that those 3 moved crates stay in the same order. So when D, N, and Z move, it's still going to be in that order because it's going to grab from the bottom. I am confident we're going to be able to solve this puzzle pretty efficiently because we just have one line of code that, or one kind of part of the code that we need to change. Everything else is modeled really nice. So as we're moving things, yeah, we're going to end up with MCD. So what we want is we're going to want this initial puzzle input, or this sample puzzle input again. Great. I'm going to come back here. Before I forget, I'm going to change this little label here to day 5, part 2. And then I'm going to go to the bottom of this. Okay, so we're back to CMZ. Okay, great. All right, let's make part 2 happen. So the only difference, it's got nothing to do with any of this parsing. All this parsing stuff is great. This does give us our stacks. It's when it comes to this step, when it comes to the actual part where we move, perform the instruction here. When we move items onto the other stack, what we were doing before was we were doing like a fold L here, and we were moving them one at a time like this. But now we can just move them all at once. So I'm pretty sure this becomes this. We can just delete this crazy list fold function. We can delete this crazy range function. And what we can do is we can use the instruction amount to determine the size of the thing we're grabbing. So hopefully this just gives us MCD and we don't have to think. Very close. Oh, here we go. From stack to stack. Just MCD. Look at that. Part 2 done in record time. That's what happens when you break your code down into like small, easy to reuse parts. So we lucked out here. So I think this is just going to work with the puzzle input. Let me save that. And again, we just deleted a bit of code. And the idea is now we're dropping all 3 at once, and then we're taking all 3 at once and just putting that right on top. This plus is the same as stack on top. Put right in front of the list. Okay, so again, we're going to take our puzzle input and please, please, please work. Because I got cocky pretty early, and it would be pretty embarrassing if it didn't work after me saying, what a joke. All right. CQQ, BBJ, FCS. Let's see how it goes. Sick. All right, well, that was great. That was day 5. We now have 10 stars. Oh, I felt like at the beginning of that, I was kind of overwhelmed with how many like steps there were. And I was like, oh, there's this, then we have to do this and do this. But I think that's just the nature of the problem. There was a lot of parts we had to do. And yeah, I'm glad that we broke them into those small steps where we tried to decode the thing into a puzzle. We kind of had like, you know, this pipeline working for us and like, you know, piece by piece doing it. Hopefully you learned a lot from that, or, you know, learned a little bit more about Elm. I will have a link in the description to both of these solutions. I'll also have a link to the Elm package docs, so that if you're ever curious about the data structure here, or, you know, want to learn more about that, feel free to do that. But that's it for me. I'll see you guys in the next video. Thanks for hanging out, and goodbye.